Welcome, welcome. I'm JJ. Let's do a quick example problem. Let's find the magnitude and direction of our Cartesian vector. F is negative 720I plus 560J pounds. For doing this, I need to get to my magnitude. I can do that just using the Pythagorean theorem in here, that my force as a magnitude should be, this is really an x component and a y component. So the square root of fx squared, negative 720 squared. If I'm laying this out, I'm going to ignore that negative because negative 720 squared, positive 720 squared is the exact same thing. It's just a little bit easier. I'm less likely to make a silly calculator mistake if I just put it as positive. So 720 squared plus 560 squared plus 560 squared, which should get us, this is 912 pounds, which is half my answer. On the other half, I'm going to come in and say I can get to my direction on this. So one thing we need to be careful with, our calculator is always going to get us, our calculator has issues with what quadrant are we actually measuring into. If we use inverse tangent is positive in the first and third quadrants. I have to think about that one every time. First and third quadrants. So our calculator will probably get us into, there's like a 50% chance it'll tell us the right quadrant. We want to be able to outsmart our calculator. So I do this by just taking the positive form of everything in here, and I'm going to graphically plot this out. So I'm going to start out here and say my first step is, I'm just going to put a quick dot right here at the origin. Let's put it over here. So I'll plot, where's the origin at? Really, I'm implying I have a y-axis that goes through this, and I have an x-axis that passes through this dot as well. And we're going to come in and plot in these x and y components in here. So I'll start with the x. Always start with the x. It's negative 720, so I'll go 720 in the negative direction. So this is 720. We're kind of just plotting it like it's a force in here, one x component. From the tip of that, I can draw in my y component. So from the tip, I go up, because we're positive, 560. So let's move where I label it 720. 720. This is 560. I have x and y components drawn in here. We can complete a triangle, and that hypotenuse of the triangle, that's our resultant force. Let's label that FR for this example. My angle, if I put everything in as positive, will be this one right here, measuring from the negative x-axis up to FR. As we move forward, we're always going to want an acute angle that we work with. So this is actually the most beneficial angle for us to find anyway. And I can get that just using the inverse tangent. Theta is the inverse tangent of opposite, 560, divided by adjacent, 720. 560 divided by, and I'm not going to worry about this is really negative 720. Again, I'm forcing this to all be positive in here, over 720. And that's going to get us that theta is 37.9 degrees. Theta is 37.9 degrees. Our calculator thinks that it's telling us it's up here in the first quadrant. We are smarter than our calculators. We know graphically that this is really in the second quadrant. So when we pull our answers together, we'll report it that way. My resultant force, FR, or F, I'll stick an R on this, FR, so it matches how I labeled it over here. But my FR should be my magnitude, 912 pounds. 912 pounds. And my angle, I know, is in the second quadrant. So I'll show something that comes from the negative x-axis and goes up into the second quadrant, because we know that's exactly what's happening in here. And I can label that angle is 37.9 degrees. 37.9 degrees. Which is getting from a Cartesian vector then to magnitude and direction on this. we can do that. There's times that we want to use the Cartesian form, times this will be easier, but we do need to move back and forth between the two of them. Again, if this video is useful for you, hit that like and subscribe button. Let's stick around and help you get an A with JJ.